Hello boys and girls, welcome to lesson 6-5, Algebra Properties. So we're going to continue with the lesson of algebras, but we're going to look at different parts of algebra. This lesson is found on page 473. Baking. Angelica and Nari are baking cookies for a bake sale fundraiser. Angelica baked 6 sheets of 10 cookies. 6 sheets, this is where you cook them, right? Baking sheet. It's 10 cookies per sheet, right? Nari baked 10 sheets with 6 cookies on each. Okay, so how many total cookies can Angelica bake? Well, she had 6, and on each one of these she had 10. So you know that that's going to be multiplication, right? That's multiplication. So she baked 60 cookies. And Nari, how many total cookies did Nari bake? Well, Nari did it the other way, where 10 sheets were used, but 6 cookies per sheet. Maybe the sheets are smaller, right? So, but it's still times 6, so it's still 60. Okay? What do you notice about your answers for exercises 1 and 2? Well, we notice that the answers are the same. There is a property here that we need to learn, boys and girls, and it only applies to addition and multiplication. And this property, or this rule, this aspect, this feature, we can call it anything, is that when you change the order, right, 6 times 10 or 10 times 6, it will not change your answer. This is called the commutative property of multiplication. Or we also have commutative property of addition. If you look in the back of your book, you'll find the definition, commutative property, which implies that the order in which the numbers are added or multiplied does not change the sum or product, does not change what you get, your answer. Remember, sum is when you add and product is when you multiply. So if you change the order of your multiplication, the numbers, such as 10 times 6 or 6 times 10, right, it doesn't change. It doesn't change. Or when you add, let's say 6 plus 10, let's say you were to add it, you get 16, or 10 plus 6, you still get 16. This is an important key answer that I want you to copy down right there. Commutative property. Okay? Number 4. What do these exercises suggest about the order in which factors are multiplied? Factors are the numbers that we multiply. What do these exercises suggest? Well, it suggests that the order doesn't matter, right? The order does not matter. There it is. Please copy that down. Remember that 6 times 10 is 60, or 10 times 6 is 60. The order in which we write it when it's multiplication or addition does not matter. So on the next page we have commutative property, and it's exactly what we said. The order in which two numbers are added or multiplied does not change the sum or product. It doesn't change your answer. Okay, that's commutative property. Now we have another one called associative property. Now associative, I want you to think about the word associate, to come together, to put together. And associative property means we group numbers, okay, such as you see here. The way in which 3 numbers are grouped when they are added or multiplied does not change the sum or product. So you see how we have 3 plus 9 plus 4. I've associated the 9 and the 4. It's still going to give me the same answer, because 9 plus 3 is 12, plus 4 is 16. Or I can group 3 and 9. You see the parentheses? I moved it to this side, plus 4, it will not change it. So that's addition. And you can do the same thing with multiplication. You can multiply the parentheses first. 5 times 7 is 35 times 8. Or you can do 8 times 5, as you see here, is 40, times 7. It's still going to give you the same product. And then finally, identity properties. Identity properties. The sum and addend of 0 is the addend. The product of a factor and 1 is the factor. What they're trying to say here, boys and girls, is identity property means this. If we add 0 to a number, it's not going to change it. It's still going to be the same one. If we multiply 1 with a number, it's not going to change the number. Do you see that? These are identity properties. Okay, little rules. And here's what properties actually mean. Properties are statements that are true for any number. The expressions 6 times 10 and 10 times 6 are called equivalent expressions, equal, the same, because they have the same value. This illustrates commutative property. Doesn't matter the order, we'll get the same product. So a typical question you might get is as this. Determine whether the two expressions are equivalent. Okay, we have this expression and this expression. Are they equal? Are they the same? If so, tell what property is applied. If not, explain why. Okay, we see here that we have 15 plus 5 plus 8. 15 plus 5 plus 8. And we associated these two. Okay, we associated these two on this side, 5 and 8, but on here we did 15 and 5, and we left the 8 out. So what are we using here? What identity? Well, associative property. You see that? Associative property. The numbers are grouped differently. They are equivalent, but associative property. By the associative property. Use equal sign to compare the expression. So 15 plus 5 plus 8 equals 15 plus 5 plus 8, except we put parentheses so that we do this first, and on this one we do this first. Number 2. Something we need to make a note of is that a commutative property only applies to addition and multiplication, not subtraction or division. Because if you actually change the order of subtraction or division, it's not going to work. Take a look here. This is associative property again, not commutative, but associative because we're associating different numbers together. We're bringing them, grouping them. The expressions are not equivalent because the associative property is not true for subtraction. Okay, so we have 20 minus 12 is going to be 8. Minus 3 is 5, right? But over here we have 12 minus 3. Okay, 12 minus 3 is 9, and then 20 minus 9 is going to be 11. So on this side we have 11, while on this side we have, did I say 5? Yes, 5. So clearly they're not equivalent, and we use the non-equivalent sign. And now remember I explained that when we add a number plus 0, it's going to be that number. This is called identity property of addition. Okay? Please go ahead and copy that down right there. If you really want to impress me in class, memorize these terms. Okay? In class, I will be asking you, what property is this? And if you raise your hand and you tell me identity property of addition, I will be very impressed. Now remember, this commutative and associative only apply to addition and multiplication, not division or subtraction. So again, 20 divided by 5 is 4, right? It's 4. But 5 divided into 20 parts, is going to be, for every 5 we have 4, it's going to be 1/4. Okay, so clearly they're not equal. So commutative property does not hold true for division. Okay, let's try A and B here. And they want us to find out if they're equivalent, right, and what property they're using. So here we're grouping them. As soon as you see those parentheses that we group, you know that it's associative. We're associating them, okay? Think of it that way if that helps you remember. So we have 5. We can do it like this. 6 times 3 is 18, and then times 5, or 5 times 3 is 30, then times 3. So we have 90, right? 18 times 5 is 90 on this side, and then on this side we have 90. So these are equivalent. So we want to answer as yes, just to say that they are equivalent, and then we're going to say what property it is, which is associative property. And now let's do B. It's division, and we know that already, that 27 divided by 3 is going to be 9, right? And so because 27 divided by 3 is 9 on this side, and 3 divided by 27 is going to be 1/9. 1/9. So that doesn't work. It doesn't work. They're not equal. So for this one, it's going to be no, and we say that the first quotient is 9, and the second one is 1/9. See it? Okay, as we continue, let's look at this key concept. Properties can also be used to write equivalent expression and to solve problems. How is that? Let's see. How is that? Here's an example. In a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their rosters. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. So 15 guards, 4 forwards, and 3 centers. 15 plus 4 is 19, plus 3 is 22. Now, I can also do 3 plus 4 first, and I get 7, plus 15 is 22. Why do you think we use associative property, boys and girls? Sometimes it's easier to group numbers that are more compatible. If I group these two, I'm going to get 7, right? I'm going to get number 7 plus 15. To me, it's easier to add these two because I know that I have a 5 here, and that's going to bring this to a 20, and then I only have 2 left over, so it makes it 22. But for some people, it might be easier to add 15 plus 4 first to get the 19, and then you count up by 3 from there. So it does, the associative property helps you add numbers or better or easier because you find compatible numbers. Let's try this one. Brandy earned $7 babysitting. I'm going to go ahead and just write that $7. I know it's important. And $12 cleaning out the garage. Write two equivalent expressions using the commutative property that can be used to find the total she earned. Okay, so she earned $7 plus 12. She earned $19, right? Or we could say she cleaned out the garage first, and then she earned $7 babysitting, so she still earned 19. You see how it's commutative? We change the order, but the sum is still the same. Please go ahead and copy this down, and you can put a star on it to show that you did it with me. For example 6, now we're going to take this and apply it to algebra, and you can see that we're using variables, okay? The area of a triangle can be found by using the expression half base times height. We know this, right? Half the base times the height. Where B is base and H is height, find the area of the triangle shown at the left. So half the base times the height. Half the base, oh, I missed the picture there. Okay, so it's 12 feet. Now, boys and girls, we want to make half one of the two. Okay, we want to make a half of one of these two. And we know that we typically call the base the bottom number. Base is the bottom. And the height the one that goes up. But is it easier to make the 15.5 or to make the 12.5? If we make the 15.5, we're going to get 7.5. So now we're working with decimal. But if we make this one a half, we get 6. And remember, it doesn't matter which one you have, because according to commutative property, it does not matter. And you can see that here. We're going to replace the base. Okay, we replace the base here. Sorry, let me just get rid of that. We replace the base here with 15 and the height with 12. But we understand that it's easier to half the 12, so we're going to just change it around, use commutative property. And now we have 12 times a half is going to be half of 12, which is 6. There it is. And now I have 6 times 15, 90. See that? Okay, let's see. Vicky earned $6 an hour while working 11 hours over the weekend. So $6, I'm sure you're seeing what I'm seeing, $6 times 11, right? $6 per hour, and there's 11 hours, so it's 6 times 11. And she put 1/3 of what she earned in a savings account. So this is times 1/3. Because if you multiply whatever we get here times 1/3, we will get 1/3 of this. Okay, and this is what she earned. Find how much she put in the account. So 6 times 11 is 66. Yes, times 1/3. Well, we're essentially asking you, when we multiply a number times a fraction, we're asking what is 1/3 of this number. 1/3 of 66 is 66 divided by 3, essentially, equals 22. If you forgot how to multiply this, remember that it's like this: 66 over 1 times 1/3. And when you multiply straight through, you're going to have 66, right? Because 6 times 1 is 66, and 1 times 3 is 3. And then you have to simplify this and divide. So you're dividing 63 divided by 3, and you get 22. Therefore, she saved $22. As always, leave the guided practice so we can do it together as a warm-up. But please complete all of the independent practice, top and bottom of the page, including the back of the page. Here's question 12.